Hi everyone. It is known that the temperature of a substance decreases due to the absorption of energy by another substance. In space, it is almost a vacuum, so it is impossible to freeze even at low temperatures. So what will happen to a certain volume of water if we hypothetically send it into open space or even to the sun? Let's figure it out together. The temperatures of rarefied substances in outer space vary greatly depending on their location. Let's simplify the situation and consider what will happen if a container of water ends up in the Earth's orbit in the shadow. Is it possible to cool down in a vacuum? I have already mentioned in several videos that there are three main types of heat transfer: conduction, convection, and thermal radiation. The first two methods require direct contact between the body, in this case a liquid, and other bodies. This means that heat transfer only occurs when there is contact. For example, in the Earth's atmosphere, water in a bucket exchanges heat with the walls of the bucket and the atmosphere. Thermal radiation acts independently of the properties of the substance. Every object, even a solid, emits thermal energy. Thermal radiation propagates in all directions and is transferred to other bodies that are in the path of this radiation. In a vacuum, thermal radiation is the only mechanism for heat transfer. For example, this is how heat is transferred from the sun to the Earth. It is this method that allows for the cooling and freezing of substances in space. The substance will begin to emit thermal energy, gradually reducing its temperature. During boiling, the temperature of a liquid depends on the pressure of the surrounding environment. For example, at twice atmospheric pressure, the boiling point of water can be about 120 degrees Celsius, and at a pressure of 4/100ths of an atmosphere, it is 28 degrees Celsius. This is a known fact, confirmed by, for example, the experiments of climbers. Water begins to boil at temperatures below 100 degrees on high mountain peaks. In the vacuum of space, the pressure is so low that it is impossible to measure it directly. Under these conditions, water will boil regardless of the temperature, and surprisingly, it is this boiling that can lead to the freezing of water. In the process of boiling, water releases a huge amount of heat and its temperature quickly decreases, much faster than when cooled by thermal radiation. This can be compared to the feeling of cooling when a large amount of gas quickly escapes from a can of deodorant. The same situation is with boiling water. Depending on the shape and size of the container, the water may quickly become covered with a frozen crust, which prevents further boiling. In this way, the water will slowly cool down due to thermal radiation. However, for this, the container must be voluminous and have a narrow neck like a wine bottle. Then, in a vacuum, the water will sublime it. That is, it will directly transition from a solid state to a gaseous state. Over time, it will completely evaporate. Therefore, it can be said that the water will first partially evaporate, then freeze, and finally completely evaporate. What will happen if we send water into space without a container? If we simply release water into space, there will be no protective shell, and the water will boil, scattering in space in the form of small droplets. Some of the water will quickly evaporate, while the rest will turn into microscopic ice crystals. These crystals will begin to sublimate, transitioning directly from a solid state to a gaseous state. And this process will continue until complete evaporation. Now let's consider the other part of the question. What will happen if we pour a certain amount of water onto the sun, for example, with a mass equal to the mass of the Earth? Can we extinguish the sun in this way? In everyday life, we are used to the fact that water extinguishes fire. This happens because it covers the burning material with a film that does not allow oxygen, the most common oxidizer on Earth. And without an oxidizer, of course, chemical burning is not possible. But on the sun, there is not chemical, but nuclear burning.